Okay, so I think, yeah, it is already recording. Okay, now it's recording. So welcome everybody to today's weekly seminar of the Center for Theoretical Linguistics. Today's speaker is TEODORA MIHOC, who is an associate professor of the Department of Linguistics at Harvard University, where a couple of years ago she obtained her PhD in linguistics, defending a thesis on decomposing logic, modified numerals, polarity, and exhaustification under the supervision of Gennaro Chierchia. And from March this year, she is also a research affiliate at the Center for Theoretical Linguistics. The main lines of TEODORA's research are formal, experimental, and computational modeling approaches to semantics and pragmatics, and cross-linguistic and typological semantics. But she's also interested in data science and natural language processing and translation. She has presented the results of her research so far in several international conferences. So, okay, now let me give the floor to TEODORA for her presentation on ignorance and positive polarity in indefinites, disjunction, and numerals. Okay, TEODORA, you can share your screen. We do not see the slides right now.
Yes, thank you, Alessandra, for your kind introduction. First of all, a small correction. Up until now, I was research affiliate at Harvard University, so not a professor. And right now, I am, thanks to your kind community, I'm now a research affiliate at UAB. I will be talking today about scalarity, ignorance, and positive polarity in indefinites, disjunction, and numerals. I know that the original title just said ignorance and positive polarity and it didn't mention a word about scalarity, but I find it very hard to talk about ignorance and positive polarity and not say a few words about scalarity. So here we are. This said, let us begin. So in the words of, as Jane Austen might say, parallel facts must be in want of a parallel account, right? And if we think about it, there are two big questions that come out. So are the facts parallel? And if so, what is the parallel account? So today I will address these questions for three phenomena of language, so ignorance, positive polarity, and as I mentioned also a little bit scalarity, in three different categories of language: numerals, disjunction, and indefinites. And by numerals, disjunction, and indefinites, I will specifically have in mind bare numerals, so items such as 3, comparative modified numerals, items such as more than 3 or less than 3, superlative modified numerals, items such as at least and at most 3. Disjunctions, for example, Alice, Bob, or Cindy. And indefinites, for example, some student. And after discussing whether the facts are parallel and what the shape of the parallel account might be, I will address one last question, which I think is actually very important. As you will see, over the course of today's presentation, I will spend a lot of time trying to compare things very carefully and try to develop an account that it is as uniform as possible. And sometimes you might look back at the existing literature and see that I've made a little modification, and you might wonder, why was it important? So why should we care? And I hope I can give you a very good reason why. So let us begin. Are the facts parallel? Numerals, disjunction, and indefinites are three quite different categories of language. So if we look in one, at a sentence such as Joe called 3 students, or Joe called A or B, or Joe called some student, we see this phrase there, 3 students, A or B, like Alice or Bob, for example, and some student. They all occupy this object position, but other than that, they look very different internally, right? In one case, we have a numeral. In the other case, we have this disjunction with a very different syntax, semantics, of course. And then we have this indefinite. However, Horn, 1972, argued that they are still fundamentally similar in the following sense. All these items have a fairly weak logical meaning, and they are compatible with a lot of different situations. For example, if I say that Joe called 3 students, they will be true if she called 3, but also, true if she called 4, 5, and so on. Because if she called 5, it will still be true that she called 3, right? Similarly, logically speaking, Joe called A or B is true if she called A, if she called B, if she called both. And Joe called some student is true if she called every student just as well. So all these items are compatible with meanings that look a little bit stronger. So 3 students is compatible with Joe called 4 students and so on. However, when we hear Joe called 3 students, or when we hear Joe called A or B, we get a strong sense that in fact this stronger logical meaning is not what is intended. So we say yes, Joe called 3 students is compatible with her calling 3 or 4 or more, but still we get a strong sense that the speaker intends us to understand that she did not call 4 or more. Thus that she called, for example, exactly 3. So similarly for disjunction, we get the sense that yes, if the speaker says Joe called A or B, yes, it could be that she called both, but the speaker really wants us to understand that she did not call both. And also, Joe called some student, the speaker really intends us to understand that she calls some, but not every student. So Horn says, yes, we have these 3 different categories of language, and I depicted them on the right-hand side via these 3 separate boxes. But they are connected by this similar behavior, which I'm representing here in the form of this dotted blue line. So here is a case of parallel facts established by Horn, and faced with these parallel facts, Horn says, if Horn feels that there's a compelling case to, these facts call for a parallel account. And he suggests this parallel account is that what these items have in common is that they are strongly scalar. They belong to natural scales. The minute we say 3, we also think of 2 or 4, as I wrote here. The minute we hear or, we also consider and. The minute we hear some, we also consider every. And because of this, so an utterance of these items brings to salience stronger alternatives from these scales that they naturally belong to. Now, what will the listener do with this information? So whenever an item brings to salience alternatives, the listener has to factor them in, and they will factor them in via Gaussian reasoning. They will conclude, yes, the speaker said 3, they could have said 4. 4 would have been a more informative thing to say, a stronger statement to make. So the reason the speaker did not say 4 is probably because the speaker that 4 is false. And thus we end up with 3 meaning not 4, with or meaning not and with some meaning not. So faced with this case of parallel facts, Horn proposes a parallel account. So I am depicting this here on the right-hand side by making this dotted blue line solid. I'm hoping these little diagrams will be a helpful visual aid as we proceed in the discussion. But Krivka 19 noticed that there is a problem with the accounts that Horn proposed. He said, look, if items that contain, if numerals brings to salience other numerals, then they should do so wherever they occur. For example, the numeral 3 should bring to salience other numerals in an expression such as more than 3 or at least 3 just as well. But then if we believe that, and if we believe Horn that the minute such alternatives are brought to salience, Gaussian reasoning kicks in, and then we get certain inferences from that, then we end up predicting that, for example, Joe called at least 3 students should lead to the inference that Joe did not call at least 4. But that is clearly wrong, because then we would predict that when we hear that Joe called at least 3 students, the speaker intends to communicate that she called exactly 3. That is clearly not correct. So Krivka points out that, look, modified numerals actually behave quite differently from bare numerals. So there's this divorce within numerals. On the one hand, on the previous slide, we noticed that numerals seem to be very similar to other categories of language. But after Krivka's observation, it appears that numerals are in fact very divided within themselves. Going forward, Gertz and Noah, 2007, point out that there is an even further divorce within numerals, so even further non-uniformity. They brought forth examples such as the one in 4. Jo called 3 students, so she called more than 2. That seems to be a perfectly well-formed discourse. However, Jo called 3 students, so she called at least 3, sounds degraded. They in fact even ran certain experiments and found strong experimental support for a contrast between comparative modified and superlative modified numerals in this context. Moreover, they also note that comparative and superlative modified numerals are further differentiated when it comes to embedding in different downward entailing environments. So they showed that, for example, superlative modified numerals are degraded under close-mate negation. So Jo didn't call at least 3 students. So consider this sentence. So first of all, consider the comparative variant. Jo didn't call more than 2 students. This seems to be perfectly well formed. However, Jo didn't call at least 3 students sounds degraded. Similarly, nobody called at least 3 people. Jo managed without calling at least 3 people. Few of the participants called at least 3 people, and so on. So there are many different negative operators, and under all of them, superlative modified numerals are degraded. However, interestingly, superlative modified numerals are not degraded under all downward entailing operators. For example, they are fine in the downward entailing environment defined by the antecedent of a conditional. So if Jo called at least 3 people, she won. This sounds well formed. Also in the restriction of a universal. Also interestingly, in the scope of a distant negation. So Tim doesn't know that Jo called at least 3 people. Again, sounds a lot better than 5A. By the way, please let me know if I'm going too fast, or I cannot actually see people's faces, so I'm not entirely sure if this is clear and all. Please do signal if there is any problem, okay? Thank you. So Gertz and Noah's point was, yes, it may be true that bare numerals are like indefinites and disjunction, but Krivka showed that comparative and superlative modified numerals are different. There are these items that have a scalar element, which I'm indicating here by this blue box. And furthermore, superlative modified numerals also have this weird property that makes them resist context of certainty, so what we saw in 4, and embedding under downward entailing operators, what we saw in 5. By the way, here's where the second keyword, I guess the patterns such as 4 were interpreted as evidence of superlative modified numerals conveying ignorance. So the reason why Jo called 3 students, so she called at least 3, was understood to be degraded is because at least 3 signals that other numbers might be possible too, which are incompatible with the context. So the patterns here showed that superlative modified numerals seem to have ignorance and polarity sensitivity. So at this point, Pierre in 2008 added something more to this picture. He said, yes, superlative modified numerals carry this ignorance effect, but they are not the only ones to do so. As was well known by then, so especially after, for example, Sauerland 2004, a disjunctive expression also gives rise to ignorance. So For example, if I say that Joe called Alice or Bob, again, we get the sense not only that, you know, the speaker doesn't intend us to understand that Joe called both, but also that the speaker may be ignorant about which one Joe called. So a lot of the literature continued this comparison between superlative modified numerals, accepted this comparison between superlative modified numerals and disjunction. However, this comparison was not done in a very detailed way. And before we move on, I believe that it is important to consider a few more facts. So people quickly jump to analysis, but I really think it's important to consider the empirical patterns a bit further. So first of all, something that is not often noticed is that if we run the exact same test, so if we put disjunction in the exact same context that we put superlative modified numerals earlier, we find that the ignorance profile of disjunction is not just similar to that of superlative modified numerals, it is indeed identical. So here in 6, this is just a modification of the sentence we had on the previous slide. So before we had Joe called 3 students, so she called at least 3. Here we just transpose this for individuals. Joe called Alice, so she called Alice, Bob, or Cindy. This is, again, strongly degraded. At first, it might just sound awkward, so people might not be convinced that this is truly degraded. It is worth commenting a bit further. Turns out this observation about the incompatibility of disjunction with a context of speaker certainty, this was already noticed by Strauss in 1952, also confirmed by Grice 1989, who also comments that it seems to be the case that disjunction, you know, he explicitly ties this behavior, this pattern to ignorance. Then Reed's 1994, coming from the psycholinguistic literature, actually tested this empirically. So this was an experiment done in the context of a series of experiments meant to test various logical inference rules and their natural language counterparts. So a sentence such as 6 would be an example of a disjunction introduction, you know, like P, therefore P or Q. And of course, in logic, that is perfectly valid. But Reeves found it very interesting to see experimentally that you know, natural language disjunction actually hates this context very much. It's also worth mentioning that the same pattern can be found in disjunctions in other languages. For example, the French disjunction ou. When people compared superlative modified numerals to disjunction, however, some authors were also concerned about the embedding under negation, the polarity sensitivity pattern. And there, however, a surprise came up. So a lot of the literature just assumed superlative modified numerals equal disjunction in some form. However, natural language or, so English or, is fine under any downward entailing operator. In English, we can easily say, Joe didn't call Alice, Bob, or Cindy, and this sentence can mean that he called none of them. So the disjunction can easily take scope under negation, and the same can be verified for other downward entailing environments. However, something that is, that is another important observation to make here, that superlative modified numerals are similar to disjunction, but up to a point. And then another very interesting observation came from, for example, literature such as Spector 2014 or Nicolai 2017, who discussed the so-called positive polarity disjunctions in French. And these are some examples, for example, from Nicolai 2017, who shows that the French disjunction ou behaves exactly like superlative modified numerals. So it is degraded under negation, it is finding the antecedent of a conditional or the restriction of a universal. It mostly behaves exactly like superlative modified numerals, but there are sometimes variations. For example, it is actually fine under downward entailing operators such as few. So few of the participants called Alice, Bob, ou Cindy. In French, that one turns out to be a little bit better. Similarly for rarely. So the picture becomes a lot more interesting, right? And we will soon come to the question of how to analyze these facts, but for now I really want us to just spend some time observing the empirical data. So after observations, the superlative modified numerals resemble disjunction. No one 2015 also noticed that superlative modified numerals and disjunction, but in their incompatibility with certainty, also resemble indefinites. So no one's observed if the comparison of superlative modified numerals to disjunction was very widely acknowledged, a lot of the literature picked up on it. This comparison to indefinites has gone under the radar, so again it is worth spending a bit more time understanding it. No one in particular had in mind the fact that many so-called modal indefinites, for example German Irgendein, are similarly incompatible with having a specific positive knowledge. So a German sentence such as, the German counterpart of a sentence, Joe called Joe called irgendein Student. This one strongly conveys that the speaker does not know who Joe called. And in fact, irgendein is degraded in this context, where the speaker knows exactly who Joe called. So if we look at other modal indefinites cross-linguistically, we find, for example, the Romanian un NP oarecare, so un student oarecare. This one again strongly rejects context where the speaker knows exactly who. Interestingly, however, the English modal indefinite some is fine with such contexts. Another interesting thing to keep in mind here is that, in fact, in the literature of modal indefinites, people don't just test whether a modal indefinite is compatible with, having specific positive knowledge about what happened, but also it has turned out to be relevant also to compare whether the speaker has specific negative knowledge. So as it turns out, Joe called irgendein student, but not Alice. So here's the context where the speaker, has in mind a bunch of students, but knows exactly which one is not an option. So it turns out in this context, irgendein is fine. So some modal indefinites are not fine in this context. Irgendein is fine, and English some is fine as well. So Joe called some student, but not Alice. So what is very interesting about, so no one, when he compared superlative modified numerals to modal indefinites, he really only compared them to, he only considered patterns such as 8a, and models such as irgendein. And he concludes superlative modified numerals are exactly like modal indefinites. By the way, Spanish algún also has this property, as is well known from work by Alonso Valle and Menendez Benito. So as I was saying, no one just considers patterns such as 8a, so he concludes superlative modified numerals and disjunction are exactly like modal indefinites. However, when we consider this full spectrum here, what we see is, just like for disjunction earlier, so earlier we saw that disjunction varied a little bit with respect to some of these patterns, for example, polarity sensitivity. So here we notice that modal indefinites vary with respect to their ignorance profile. Some are incompatible with having specific positive knowledge, as well as with having specific negative knowledge. Some are incompatible with specific positive knowledge but are fine with specific negative knowledge, like irgendein, and some are fine with either sort of knowledge. And about this last category, exemplified here by English some, what is interesting, it is important to make one more observation here. So when people think of a modal indefinite, they think of an indefinite that triggers this sort of strong speaker ignorance or indifference effect. But in fact, in the literature, in the recent literature, being a modal indefinite has been equated with being degraded in contexts such as 8a. Now, here I want us to notice that some English sum actually creates a tension here. So since Strawson 1974, for example, it has been noticed that a sentence such as "some cabinet minister has been shot" conveys a strong speaker ignorance or speaker indifference effect. So some in fact, Alonso Valle Menendez Benito 2015 really called Strawson's discussion of some as the first discussion of a modal indefinite in the literature. However, note here crucially that some is compatible with certainty at the same time. So some creates some sort of a tension. Either way, for now, let's just observe that modal indefinites are indeed very diverse as well, just like disjunction before. And this diversity, again, is reflected also in their ability to embed under downward detailing operators. So again, in 10, I just put various epistemic modal indefinites under various downward detailing operators. And if you just look at these signs here, the hashtag and the check mark, we see again that their behavior is quite mixed. Some, like un, np, waregare, resent embedding under any downward detailing operator, except for the antecedent of a conditional or the restriction of a universal. Others are fine under some negative operators. For example, Irgenstein is fine under nobody. And some, like English some, yet again, resent embedding under negation. So when we look at this diagram on the right-hand side again, we will conclude this time, yes, superlative modified numerals and disjunction are like modal indefinites. However, there is no straightforward pairing between them. Sometimes we find exact matches, but most of the time we just find that the landscape is quite diverse. So finally, so all our previous discussion of some actually turns out to be very useful. So for a long time, because of the observations we made earlier about comparative modified numerals, the literature concluded that comparative modified numerals had no ignorance. You know, they were compatible with specific positive certainty. In 11b, here we see that they are compatible with specific negative certainty as well. So Joe called more than 2 students, but not 5. This is perfectly well formed. So for this reason, people just said, an expression such as more than 2 has no ignorance. However, this conclusion has been challenged, for example, by Meyer and Meyer 2014, or experiments by Wester and Brașoveanu. These experiments make the point that a sentence such as Joe called more than 2 students, especially in certain contexts, it can actually convey speaker ignorance or indifference. It doesn't have to, but it can. So in light of what we saw earlier about modal indefinites and about the fact that some modal indefinites are like English some and they are compatible with having some knowledge, we conclude that actually comparative modified numerals belong in this bunch as well. So far, I don't know if you remember this. So earlier, the first time we called it superlative modified numerals in red, the label, the text label, that stood for, hey, I am an item that has ignorance and polarity sensitivity. And then we extended this coloring to disjunction and indefinites because they too seem to have this property. Well, in light of what we saw about modal indefinites, I will argue that we are in a position to color comparative modified numerals like this as well. Yes, they do not have polarity sensitivity, but we saw earlier that disjunction and indefinite sometimes vary with respect to that as well. And yes, they are compatible with specificity, but again, modal indefinites can do that as well. So, we will color comparative modified numerals in red as well. Moreover, here in the second diagram on the bottom right, I am noticing that, first of all, we've seen over all the patterns we've looked at, we've noticed that ignorance varies, polarity sensitivity varies, and they very much seem to vary independently. And if we try to find an exact match between various items, sometimes we can, but we don't have to in a way. Because the correct way to match them is simply by property, like match them with respect to ignorance and match them with respect to polarity sensitivity separately. So this is what I'm trying to do here in this little diagram. So the straight dotted lines stand for ignorance, and a single line indicates a weak ignorance profile in items that are, however, compatible with some certainty. We see this here in comparative modified numerals and in some. A double straight dotted line indicates a strong ignorance profile, such as that of superlative modified numerals and disjunction. So these are items that are not compatible with specificity. And then we also saw that, interestingly, so the wavy lines stand for polarity sensitivity. So a double line stands for items that are strongly positive polar, and a single dotted line stands for items that do not exhibit positive polarity. So one last thing to notice here, note that when we look at comparative modified numerals, we see that they are connected to two single lines, a single straight line and a single wavy line. So they have a very weak profile. In the sea of items with a very strong character, comparative modified numerals have a very modest profile, and I believe that is one of the reasons why it was so hard to classify them. For some English sum, people have long known that there's something weird about it because, for example, as discussed in Sabochi 2004, the fact that it couldn't embed under negation was well known, so that already posed a challenge. Then, people generally accepted that it was a model item, so that again called attention. But comparative modified numerals have really stayed under the radar for a long time. Finally, it looks like we've managed to connect all the items in our original, to reconnect all the items in our original diagram in all sorts of ways, but we still inherited from the first few slides this idea that comparative superlative modified numerals are somehow fundamentally different from bare numerals and disjunction and indefinites by not giving rise to these scalar inferences that Horn was predicting. So the literature has really taken that pretty much as a dogma. Sometimes people have gone back and looked at further patterns. They have noticed that, look, these items sometimes do give rise to certain inferences, but these inferences were always reclassified. People never really thought about them in terms of Horn, according to Horn again. So here, one last thing I want to do before we move on to the theoretical part of the story today, I want us to reconsider a little bit whether the original conclusion that comparative superlative modified numerals do not give rise to Horn inferences is warranted. So in 13a, we repeated this original pattern. So Joe called 3 students, not 4, therefore exactly 3. This was the patterns discussed by Horn, which were, correct for bare numerals. Here are the patterns for comparative and superlative modified numerals. So Joe called more than 2, not more than 3, therefore exactly 3, so the bad pattern. Because of this, people concluded that bare numerals and that comparative and superlative modified numerals are very different from bare numerals. However, if we run Horn's reasoning in a lot of other environments, we see that in fact it sometimes doesn't go through for bare numerals either. So Joe didn't call 3 students, according to Horn's reasoning, should lead the listener to understand, to conclude that Joe called exactly 2. But that is, of course, not the meaning we obtain from that sentence. There are problems with the Horn picture for bare numerals as well. Moreover, there are many contexts where all numerals, bare, comparative modified, and superlative modified numerals behave exactly as predicted by Horn. So in 13c, we have an example of an embedded upward entailing environment in the, embedding under in the scope of every. Here we have an example of an embedded downward entailing environment, so the antecedent of a conditional. So here the inferences go through just fine. And in E and F, I make one last comment that all the problem cases seem to go away if we just change the granularity of the scale a little bit. So yes, Joe called more than 2 students cannot mean that she didn't call more than 3, therefore she called exactly 3. But it can mean, for example, that, Joe called more than 2, therefore not more than 4 or not more than 6. So there is, first of all, this blue line that was connecting bare numerals to disjunction and indefinites is itself actually dotted. And the same is true for bare and comparative and superlative modified numerals as well. So here we have a bunch of redrawn puzzles, really. And the question is how to address them. But before we come to this question, yes, before we come to this, in fact, so turns out when we look at a variety of other indefinites, disjunctions, and numerals, and again, we ask these questions about ignorance, these detailed questions about ignorance and positive polarity and scalar implicatures, we again find a very diverse picture. So, given the diversity of this picture, we come back to the original question, are the facts parallel? And the answer might be no. One might think that the correct answer is no. But I would like to argue that yes, the facts are parallel, but in a much richer sense than usually acknowledged. What I mean to say is that in all of numerals, disjunction, and indefinites, we seem to find a modal variation effect in seemingly episodic contexts. And this variation effect, can come with or without compatibility with specificity, and it can come with or without compatibility with downward entailing environments. And we find this in numerals, in disjunction, and in indefinites. And finally, in all of these categories, we also find Horn-style scalar implicatures. So if the facts are parallel, what is the parallel account? So we need, on the one hand, an account that can capture all the various similarities between these items and categories, but also the considerable differences, sources of variation that we found. And for now, I will try to keep the discussion pretty high level because I think it is more fruitful than going into details. So looking back at the facts to be explained, so this little diagram that summarizes the problem, numerals, indefinites, and disjunction are similar, Horn said. And he proposed a story for that. Said they all activate scalar alternatives, factoring this in its scalar implicatures. This view has been maintained for indefinite and for disjunction. But when people looked at this picture, so the facts that showed comparative and superlative modified numerals were different, a lot of the literature just concluded that modified numerals do not give rise to Horn scalar implicatures, and they came up with different mechanisms to support, to reflect this. For example, people have argued sometimes that yes, comparative and superlative modified numerals do contain a numeral, and therefore they do activate scalar implicatures, but maybe no, they do activate scalar alternatives, but maybe these alternatives do not project. This is, for example, the view that we find in Krivka 1999. Or other people have said, yes, all these first two steps are true. They do activate scalar alternatives, but the scale is universally dense, and this causes some, this has the effect that for comparative and superlative modified numerals, no scalar implicatures are derived. So this is the point made by Fox and Haeckel, for example. More recent literature does something different. They usually just say, yes, a comparative and a superlative modified numeral contain a numeral, and they do get alternatives from the numerals, but they also get alternatives from something else, for example, from the modifier. And this is the view we find, for example, in Meyer, in Kennedy, or in Schwartz, and so on. In light of what we argued on the last slide here, we might want to not believe this conclusion just yet, that modified numerals do not give rise to Horn scalar implicatures. So when people finally looked at ignorance and polarity sensitivity, superlative modified numerals, various authors try to make the point that superlative modified numerals are simply special. Their semantics is different. Maybe they contain a hardwired modal in their meaning. Or maybe they are speech act operators. That is the view we find in Cohen and Krivka. So the modal view we find that in Gertz and Noone in Noone 2010. When people notice the similarities between superlative modified numerals and disjunction, So this was a lot of the literature. They said they try to argue that superlative modified numerals are disjunction. Like they said, you know, when you say at least 3, you're saying, many people write at least 3 in terms of the mathematical relation, greater than or equal to 3. And they say, really, superlative modified numerals are just the disjunction of you know, the pieces of this compound relation. So at least 3 is really, in a sense, equal to exactly 3 or more than 3. And from that there onwards, they would say they activate disjunctive alternatives like disjunction, and from there we get ignorance and positive polarity according to recipes we find for disjunction. The problem with this view is that it was still very unclear in what sense superlative modified numerals should you know, be treated as really clear even in what sense this analysis should apply, and also the existing views of positive polarity in disjunction were usually able to derive ignorance and positive polarity, but not to capture disjunctions that had the same strong ignorance but no positive polarity. Then when no one noticed the similarity to indefinites, he tried to make the point that superlative modified numerals and disjunction are indefinite-like. And again, so activate subdomain alternatives like indefinites, and from there everything follows. The problem with this view is that, again, it was very unclear in what sense superlative modified numerals and disjunction would be indefinite-like, and exactly how the alternatives were to be generated and how exactly one was to obtain all the patterns that we found here. So NO1 2015 really only covers a very small portion of the patterns we discussed. Finally, so in my own work, I focused a lot on all these little, you know, pieces of the puzzle in the literature, and I proposed to activate subdomain alternatives, and I showed in what way. And then I showed how from this we obtain ignorance and all these variations, sometimes compatibility with negative specificity, with sometimes positive. And also sometimes we obtain this variation with respect to polarity sensitivity. And you know, also in my work, I try to explain, to make the point that all these items really, including numerals, items that have domains and items that have scales. Items like this, I argue, they naturally activate scalar and subdomain alternatives, and factoring this in very specific ways yields all the patterns we saw. All of this has been very general and very high level, so let us see a demonstration. First of all, one big problem in the literature trying to unify disjunction with indefinites and modified numerals was to understand in what sense they were similar. You know, what is the cause for their similarity? And as I just mentioned, I argue that the fundamental similarity is that they are all items with domains and scalar items in them. And this may not be obvious, so on this slide I try to make it more obvious. So when we look at a sentence such as Joe called some student, so in semantics you will be given a meaning, for example, of the form, there is an X from the set of students and Joe called this X. So we have this, we're talking about an X pulled from a set of students, a domain. In a sense, when you say that Joe called A, B, or C, or such, it is easy to see that disjunction also makes reference to this sort of a domain, right? But it was not very obvious in what sense more than 3 people quit, or more than 3 made reference to a domain as well, or why a bare numeral such as 3 doesn't make reference to such a domain. So here I came up with a new decomposition of bare and modified numerals. Here we can discuss that shows in what way this domain comes up, and only for modified numerals. Basically, I argue that a bare numeral simply tells you that you know, a sentence such as 3 people quit, it just tells you, you know, there is an X, it's a plurality with 3 atoms of people who quit. This is the semantics of bare numeral. It only makes reference to a scalar element. However, for the semantics of, for example, more than 3 people quit. So the sentence tells you that the maximum degree such that there exists plurality with cardinality D of people who quit is a number in a set set defined over 3, defined via the modifier much or little from 3. So a comparative or a superlative modified numeral, I argue, at the same time make reference in their truth conditions both to a scalar element, so this numeral that we are talking about that is very obvious that they wear on the sleeve, but also to this set of degrees defined around this numeral. So yes, more than 3 makes reference to 3, but it really also makes reference to all this set of degrees defined over 3, like 4, 5, 6, and so on. Basically, degrees such that they are greater than 3, right? I show here that so here's the schematic representation of the truth conditions and the alternatives that come from these truth conditions. So actually, to go back here one moment, I argue for an alternative generation mechanism where any item that makes reference in its truth conditions to a domain naturally generates domain alternatives. So alternatives that look exactly like the original sentence, except that the identity of this x or of this number here is pulled from a subset of the original set. And also I argue that any item that makes referencing, that leads to truth conditions that make reference to a scalar element also naturally activate scalar alternatives obtained by replacing the scalar element. For example, the existential quantifier or the join operator or the numeral with a scalemate. For example, the universal operator or the conjunctive operator or the another numeral. What's interesting is that once we find these truth conditions and generate alternatives in this way, disjunction, indefinites, and modified numerals truly look very, very similar from a logical point of view. So, like I said, here in black we have their truth conditions. For example, here are the truth conditions for less than 2. Basically, it just means 0 or 1. This expression activates subdomain alternatives 0 and 1, and also scalar alternatives. So less than 1, which is just 0, and less than 3, which is 0 or 1 or 2. And so on. Here's another example for a k for a larger modified numeral. And what's interesting is that the logical relations between these alternatives and the truth conditions are the same in all these cases. So now, again, a big discussion in the literature has been about how we found truth conditions that tell us in what sense these items are similar. We also found similar alternatives, but how must they be factored into meaning? People, of course, Hora was talking about Gracian reasoning. Since Hora people have come to a more sophisticated understanding of how implicatures are computed. People have argued they are computed in the grammar using so-called exhaustivity operators, most notably an operator akin to a silent only, represented here via an O. So people have also debated about the nature of this silent exhaustivity operator. What exactly does it do? When you give it an assertion, what does it do with it? So the traditional view from Grice is, Gracian reasoning went like this. The listener considered what was said, and then considered stronger meanings and excluded them. That was the implicature. So concluded that they were false. So in the literature on using exhaustification, people have argued how exactly does this operator function? Is it exactly as on the original view, or are there any differences? How must the alternatives be factored in, and so on? For example, with the subdomain alternatives, it has been argued that they must be factored in an exhaustively understood way. So if you look at A or B, and the subdomain alternative A and the subdomain alternative B, people have argued that really the listener that doesn't just consider the alternative A and the alternative B, the listener considers the alternative only A and only B. and so on. So there are very many choices about what could happen to the alternatives, and I show in this work that in order to obtain the results we want, you need to say that you're using contradiction based only, so a definition of this exhaustivity operator exactly like on the classical view. This is an operator that asserts that it's prejacent and says that all the alternatives that are not entailed by it are false. I also argue that you must use the subdomain alternatives in the pre-exhaustified form, and I illustrate here how that goes. And I argue that any item that has, that naturally activates subdomain alternatives and scalar alternatives, the exhaustivity operator has to consider all those alternatives. And here I illustrate how it happens. And then for ignorance, I simply argue that when you think about here the game is basically to understand in what way a sentence such as Joe called A or B, or Joe called at least 3 students, how does it come to have give you this sense that the speaker isn't sure? So the literature has long argued that this is a modal sort of effect. So here I show that what happens is that I argue actually, without going into too many details, I argue that ignorance is really a free choice effect computed over a null model, null epistemic necessity model. This is a view that goes back to Kratzer and Shimoyama, 2002, for example, and so on. What is new here? This is a view that has been widely adopted in the literature on disjunction, on indefinites, including the literature on modal indefinites, and including the literature on numerals, on superlative modified numerals, for example. What is new here is that I really show that ignorance is really an epistemic free choice effect. So people are talking about free choice effects and ignorance, and they argue they're really the same. Moreover, Alonso Valle and Menendez Benito have shown us how to, given items that make reference to a domain and that activate subdomain alternatives, they have shown us how to obtain compatibility with negative specificity. Alonso Valle and Menendez Benito show that when you have an indefinite, that pulls its value from a domain with at least 3 elements, if you consider just the singleton subdomain alternatives, you obtain compatibility with negative specificity. I show that if you consider just the non-singleton subdomain alternatives, you also obtain compatibility with positive specificity. So basically what you get here is, so if ignorance is this state of the mind where the speaker isn't sure that A, so doesn't know that A and doesn't know that not A, and isn't sure that B in a similar way. So compatibility with specificity is this state of partial ignorance, where, for example, the speaker is sure that not X, so in all the epistemic states of the speaker, they are excluding X, but they are not sure about Y and they are not sure about Z, and so on. So this compatibility with specificity is this sort of partial ignorance state of mind. And also, people have shown that polarity sensitivity comes just as well from considering what happens. So far we show that considering subdomain alternatives is what drives ignorance. The literature on disjunction and indefinites has shown that considering subdomain alternatives is also what drives polarity sensitivity. In particular, it was shown that when you try to consider subdomain alternatives, the subdomain alternatives of a negative disjunction or of a disjunction under negation or an indefinite or under negation or such, what happens is that considering these alternatives is a vacuous process. It does not lead to any implicatures. Why? Because it turns out these alternatives are entailed or they're already excluded. So factoring them in, it doesn't lead to any strengthening. So in the literature on disjunction and indefinites, there is this idea that a vacuous use of the subdomain alternatives is what drives polarity sensitivity, in the sense that some items resent this. They really, if they activate subdomain alternatives, they want them to be used and they want them to lead to a stronger meaning. So my main contribution was simply providing a unified view, showing that the exact same reasoning that was argued to work for indefinites works just as well for disjunction and for numerals. And as for why certain items that are sometimes bad under negation are nevertheless sometimes fine under other sorts of negative operators. So if we look back at the empirical chart, we see that many items, many of the cases where an item was fine under negation, so or under negative operator, happened when the negative operator was not entirely negative. So everybody knows that, for example, few is a negative operator. Few of the participants called Alice, Bob, or Cindy. Yeah, this is a negative operator, not many. However, it is also well understood that few, for example, triggers a positive implicature. So if you say few of the participants called Alice, Bob, or Cindy, you still get this meaning that, some did. So it was, and similarly, if you look at if Joe called Alice, Bob, or Cindy, she won. So again, we have this negative operator, and the antecedent of a conditional is known to be a negative sort of environment. However, it is also in some sense positive, because if you say that if Joe called Alice or Bob, she won, a sentence like this kind of carries this positive meaning that, it is possible that she called Alice or Bob. So basically all the exceptions, so when you had an item that was degraded under negation, like U was bad under negation, but all the exceptions to it being bad under negation happened when an operator carried some sort of positive meaning. So going back to the analysis, basically the idea in the literature is that if you consider subdomain alternatives for this sort of utterances, but you don't just consider the assertive meaning, but also the non-assertive parts of the meaning, like implicatures and presuppositions, then as it turns out, the result is no longer vacuous. You actually do obtain implicatures. So basically an item that requires its subdomain alternatives to lead to a stronger meaning, and that lets you look at non-assertive parts of the meaning in trying to make this successful. So that sort of item will be an item that sometimes is it's bad under negation, but will be fine under negative operators that contain some positive meaning. And finally, a small point about scalar implicatures. So the most recent literature argued that superlative modified numerals don't have scalar alternatives. They only have this sort of disjunctive or domain alternatives that lead to ignorance and polarity sensitivity. Instead, I show that given the alternatives I am assuming, the subdomain alternatives I am assuming, if you bring back the Hora implicatures, it is very easy to see where the problem arises. The problem is that, so in previous slides, we saw that superlative modified numerals give rise to ignorance. So at least 3 give rise to, like, the speaker doesn't know a 3, the speaker doesn't know a 4, is not sure if 3 or 4 or 5 and so on. However, a scalar implicature leads to certainty, right? A scalar implicature led to the meaning that at least 3, not at least 4, therefore exactly 3. And basically there is a clash, this clash between the result of ignorance and the result of factoring in domain alternatives and the result of factoring in scalar alternatives. And I'm arguing that this is the reason for the occasional scalar implicature gaps. Now, when you have a clash like this, you might expect that those sentences will be completely, unacceptable, but that of course is not true. So I'm arguing that there is actually a trade-off. There's a little bit of give from the scalar implicatures and from the ignorance as well, which results in this sense that at least 3 still conveys not at least 5, maybe. And to conclude, I'm sorry, I know this is running a little bit late, so let me try to speed up. So basically, to the question, what is the parallel account? I am giving an answer that is actually a very that has become since during 2008, for example, a traditional answer. It is so. The parallel account is an alternative-based account. However, I am arguing that this is an account that is much more unified than in previous literature. So before you had accounts that could, capture part of the fragments, but that broke for other parts of the data. They couldn't account for comparative modified numerals or for certain inferences, or they couldn't really explain in what sense comparative modified numerals or comparative modified numerals were disjunctive or like indefinites or such. And here in my work, I've tried really hard to show exactly in what sense this happened and exactly what assumptions we have to make about the exhaustivity operator, about the use of alternatives and so on for this account to be truly parallel. And now, from what I've said so far, it really may sound like all this work was very nitpicky. We just spent a lot of time, it can get boring looking at all these different items, figuring out exactly what's what, and we may wonder, why did we have to bother? Why should we care? And I believe that this is a strong reason to care. The strong reason to care is the following. It goes back to a tension between Montague and Grice, really. So Richard Montague, in his work in the 70s, he famously stated, I reject the contention that there is any important theoretical difference between natural languages and artificial languages. And he goes on to show in what sense natural languages behave can be described with the tools of logic. So he basically makes the point that natural languages are logical. And of course, lots of the literature after, by the way, just to think about this, so as we were saying earlier, a disjunction like, Joe called Alice or Bob is true if she called Alice, it's true if she called Bob, and it's true if she called both. So that is exactly like P or Q, true if P, true if Q, true if P and Q. And Joe didn't call Alice or Bob is, true if she called neither, and that is exactly like not P or Q. So natural languages do look very logical, but then of course a lot of the literature showed that natural languages deviate in all sorts of ways from the meaning we were expecting from logic. So a lot of the literature really said, look, natural languages are supralogical in the sense that they are idiosyncratic and really quite a little bit illogical. So here's where you find all these different accounts that say, yes, disjunction is like logic, but a bit different, or maybe we should put some model operators in there, or maybe, for superlative modified numerals, people have wondered, yes, maybe at least three or four or five, but in a slightly different way. It doesn't exactly mean quite that. So you have all this idiosyncratic analysis. But Grice, of course, famously made this point that natural languages are supralogical in the sense of principled and very logical, right? So he says supralogical in the sense of superlogical. He says basically the key here is to remember that the purpose of natural language is communication, and in communication it matters very much not just what you say, but also what you don't. So basically Grice and a lot of the literature since has made this point that we crucially reason with alternatives. We hear about what we say, we wonder why something else was not said. And Grice says when we look at language in this way, everything that we see is really very logical. So, Grice's idea has had a huge impact on the literature. It has been very successful for many different effects, many different phenomena, and many different categories of language. However, like I said, there is this challenge that more than it was even acknowledged in the past, we find this challenge, like the challenges we discussed today, we see that these supralogical effects are very rich and they vary between and within categories of language. So you find, 10 different kinds of indefinites. They are slightly different here and there. So the consequence has been, so we find this very often in the literature, that it is tempting to give up on this idea that supralogical equals principled and very logical. So this uniformity that Gricean reasoning was trying to bring to all these idiosyncratic effects. So my main point today, so if there's just one idea you must remember from today's talk, is the following. My main point today is that really we do not have to give up on this idea that supralogical is principled and very logical. Really, when we look very carefully, language gives us all the clues. If we look carefully at the truth conditions and we try to understand the alternatives really, really well, we do find that there is this possibility for exactly, precisely the variation that we find. And it is, in fact, really very logical. Thank you.
Okay, thank you very much, Teodora, for your presentation. Now, if there are questions or comments, please feel free to raise your hand. Xavier?
Can you hear me, Dora?
Yeah, we can hear you.
Yes.
It's just more than a question. Is just curiosity, because during the talk you have been talking about indefinites, and you have talked particularly about sum.
Yeah.
It's a very tricky one because you can have weak and strong readings. Did you find particularly ways to deal with this in your framework? I mean, because you have the presuppositional one, which is, I mean, lacks ignorance. And so can you say something about this, please? Because I think it's a very interesting point, and connecting with your point as well. Have you think about it?
Yeah, I know that there are with some more specific, like how to make it compatible with specificity and indifference and all that. So could you just say a little bit more about which tricky part about some you have in mind? So
Teodora, I think we cannot hear you.
Yeah, the sound is
how about now? Is it better now? In
No.
and out.
If you want to try to repeat.
This is better? Okay. So, right, Xavier, so I was wondering if you could be more specific about which tricky part of sum you have in mind, because I know there are very many. So just to make sure I'm not wasting your time in my answer.
I mean, the classical one, the distinction between weak and strong, for example, you can have it in existential vision. So there are some people there, but then it doesn't have particular people. And then you have the other one. Some people are in the bedroom, and some others are in other place. And then you can have a particular set of people. So more.
Yes. No. I actually haven't. No, I haven't thought about this at all. This side of the problem at all. So I am aware there are many more issues about sound to dig into. So the one particular issue that I spent a lot of time thinking about was the modal nature of sound. In the sense that there was this really attention in the literature. People liked to use sum as an example of a modal indefinite. For example, Alonso Valle and Benito start their article when they introduced the notion of a modal indefinite to introduce algún, Spanish algún.
Right.
They in fact first illustrate the case with English. They look at, but then when they apply the test where they try to prove the modal character of algún, they actually use the test of incompatibility with positive knowledge, like knowing who. And in fact, there is a test that some fails. So by that test, some should have been declared. No, of course, it's not what anyone wants, because like I was saying earlier, some is basically regarded by everyone as the original example of a modal indefinite in the literature. So what was really difficult about some is because it feels modal, but it fails all the tests that people use to prove that something is modal sometimes. And the question is, so how do you handle that? I showed, look, some does, out of the blue, it conveys this strong ignorance or speaker indifference effect. And then, however, it is compatible with specific negative specificity and with specific positive specificity. And that is, I argue, so, Alonso Valle and Benito already solved the part of the problem where they showed how to obtain specificity. They say, just consider singleton subdomain alternatives. So there I just adopted their view, but then I showed that, and you have to be careful about how you do this, but basically if you consider the non-singleton subdomain alternatives, you obtain this compatibility with positive specificity, which is a meaning, for example, where you know for sure that the statement you're making is true of one individual in the domain, but you're unsure about the rest. It's like saying, Joe calls a student. I know she called Alice. I don't know about, if she called anybody else. And then there's another question. So, an item that is compatible with specific, positive knowledge. Then, in what sense is it still model? There's some variation, and turns out that what happened. Yes, in recent work, I was also thinking about singular and plural model indefinites, and basically, in some cases, you end up with a meaning that it's not at all model; it's very certain. And I argue that in that case, really, a different sort of model effect kicks in. It's speaker indifference. And this is an effect that hasn't really been, people sometimes mention it, but there's no clear analysis of how it comes about and how it interacts with ignorance. So there are plenty of interesting threads. Yeah.
Of course. Thank you very much.
Yeah, I would very much like to dig into the ones you mentioned. I just haven't gotten around to it.
Of course.
Maria Teresa?
Thanks, Theodora, for your talk. Actually, my question has a continues what Chevy asked. I'm really interested about a clear definition of a speaker ignorance, because okay, so in fact you didn't provide the definition of a speaker ignorance. You related it to indifference, you related it to disjunctive alternatives, but I haven't studied numerals, but I've been doing some research on indefinites. And it seems to me that one thing is the difference that has been made even by Enge on a specific un and non-specific un, for example, in Romance languages. And then you have what I would say the anti-specific un. And what is the difference? In my understanding, the difference is that when you deal with un, you consider walls that are part of the epistemic state of the speaker, okay? Mm-hmm. And you consider that there might be variation, so there is no identity among the individuals that you consider by un on the non-specific reading, okay? Mm-hmm. But when you consider algun, in fact, you consider the existence of a wall that is not part of the epistemic state of the speaker because he wants to be ignorant. When you say something like, en esta ciudad, algunas tradiciones medievales todavía se conservan, something like that. Mm-hmm. In this case, you are describing something that is characteristic of a city, but you either don't want to be, the speaker doesn't want to be specific about which medieval traditions are celebrated in this city, or doesn't want the hearer to share with him which specific medieval traditions are kept. So I think that there is something that is not, that maybe we do not understand clearly. What is the difference between this speaker ignorance, because I think that sometimes relates to the epistemic states. So you consider walls that are part of the epistemic states of the speaker, but sometimes you consider walls that are not part of the epistemic states of the speaker. And this is the case of algun. And I think that this has not been discussed in the literature. And I think it would be worth investigating, because I think it's the difference between non-specific un and anti-specific algun.
So I'm wondering a little bit, yes, I have some thoughts about that, and I agree with some of the, I've had some similar thoughts about English sometimes, but I do wonder, what do you mean about, words that are not part of the epistemic state of the speaker?
That when I use algun, I think that I don't want to be specific about any individual, either because I I don't have any knowledge about this, or I don't want my knowledge to be shared by the hearer. I don't want to be specific. So it's clearly, it's non-specific, it's anti-specific in this sense.
Yeah, I see, yes. So I think this connects a little bit. So I did not know this about Algon, but it seems to me, from what you're saying, it seems to me that Algon can also convey, on the one hand, speaker ignorance, and on the one hand, speaker indifference, or like, as if the speaker is saying, for the purpose of this conversation, you could take any element of the domain. You could fill this subject position with any element of the domain. It's like saying some traditions have been preserved, like for the purpose of this conversation, it could be, you could take it to be tradition X or tradition Y or tradition Z. Is this what you're so this is, see when, in the first original description of some, in Strawson 1974, he talks about this sentence. Like he asks, what is the difference between a sentence such as, you know, a cabinet minister has been shot versus some cabinet minister has been shot. And he says that in the second sense, in the second case, it's as if the speaker isn't sure which one, so leaves all of them as open possibilities, or knows who but doesn't consider it relevant for the purpose of the present conversation to be specific. So basically, it's as if he's saying to you, for the purpose of this conversation, you could take it to be A, you could take it to be B, and it would be all the same. So this is, I think, this speaker what I called earlier speaker indifference effect, which I really think has not been analyzed, and I think that's what maybe what you're saying also, because yes, and it is not obvious where it's coming from, but it clearly relates to the purpose of the conversation in some sense, and to what the speaker, you know, wants to, yeah, the purpose of the conversation according to the speaker, like what he wants to contribute. And yeah, I think it's interesting, and I think I've heard reports that some model indefinites do not allow this speaker indifference, although sometimes people in the literature of model indefinites, people often talk about agent indifference. For example, Kierke talks about certain model indefinites in I believe it could be like so like Joe ran down the street and beat on model indefinite door she could find. And he says that in that example, it could be like, you know, the agent, Joe, didn't care which door she picked to knock on. So in that case, that's an agent indifference effect, and the literature does mention it, and people usually just analyze it as a booletic free choice effect. You know, you're looking at the booletically accessible worlds related to the agent. People sometimes talk about the speaker indifference, but very rarely, and it's different than agent indifference. It's very different, and it's not clear where it comes from. And it's moreover very being compatible with specificity in some form or not, you know, because that's another. So on the view I presented here, I just showed the model indefinites are very diverse, and some in the language sometimes you just find specialized model indefinites, some that choose to be, you know, they're going to be these quirky ones that will allow you to use like fewer of their alternatives, and look, you obtain a weaker model effect. But I think people have really not, we don't yet understand how ignorance relates to indifference, to speaker indifference. To, you know, what factors will determine whether an item, is it all the same? Is it like a lottery? An item could turn out anyway, or is there some internal pressure from the language based on the existing inventory? You know, you have an item that's a strong free choice item, so then other items might end up being weaker. There was a question that came up for superlative modified numerals. For example, people have wondered, is it always the case that a superlative modified numeral is going to be incompatible with knowledge? Because according to the view I presented, it could go either way, right? I haven't given any reason why a superlative modified numeral should force you to always use all of its alternatives and give rise to a total ignorance effect. And it turns out, I wondered about it. So turns out actually in Chinese, there is a variant of a superlative modified numeral that is compatible with specificity, which is very odd. So in all the examples I showed at the beginning, like Joe called 3 people, therefore she called at least 3, which was degraded in English. Turns out in Chinese you have 2 variants of the superlative modified numeral, and one is fine there. So yeah.
Thank you. Thank you.
Okay, so are there other questions or comments for Teodora? If not, I will again thank Teodora for her presentation.
Thank you very much for hearing me out. So I know that this can be a lot and lots of content, and yes, thank you. I really hope we can talk further.
For sure, for sure. And then for everybody else, I will tell you that we will meet again next Friday with Fabienne Martin with a presentation on monomorphemic verbs in Mandarin Chinese, lexical aspect, event structure, and non-culminative uses. Okay, so that's it, and thank you. Have a nice weekend.
Thank you.
Nice weekend to everyone.